Microchips are the invisible brains of the modern world. They're in our phones, laptops, smart fridges. Well, maybe not that last one, but that's beside the point. But while we might be familiar with what they do, their manufacture is less well understood. Now, researchers in Australia have demonstrated a revolutionary method that uses the power of quantum machine learning to streamline this process. In a study published in Advanced Science, the scientists showed how a quantum algorithm can model, with unprecedented accuracy, the electrical resistance inside a chip, a crucial factor that dictates its speed and efficiency. So let's take a look at this incredible breakthrough. First up, we need to talk about quantum machine learning because it sounds super sci-fi, but it's actually a really elegant idea. Quantum machine learning is exactly what it sounds like. It's machine learning, which is basically a type of artificial intelligence that uses data to make predictions, but it adds a twist by harnessing the bizarre rules of quantum physics. Like the uncertainty principle, remember that? Yeah, that one's pretty fun, but here's the basic idea. In a regular old computer, information is stored in bits that hold the value 0 or 1. You can think of bits like switches that are either on or off, true or false, open or closed. Quantum computers use qubits instead of bits, and qubits are a bit more complicated. Because of counterintuitive principles such as superposition and quantum entanglement, a qubit can be 0 and 1 at the same time. Two qubits can therefore represent for states simultaneously 00, 01, 10, 11, and the parallel processing capacity grows exponentially with every additional qubit. So why is this important? Well, imagine you have a big box of Lego and you want to find all the red ones. With a normal search, you would go through the box one brick at a time. But with quantum search, you can put all the bricks in a superposition of states and then you can search multiple bricks at once. This saves a lot of time, especially if you have a ton of bricks. Quantum computers excel at breaking problems down into smaller parts and solving them all at once. Quantum machine learning, or QML, takes this a step further. It converts real-world data into quantum states, allowing the quantum computer to uncover hidden patterns that would be invisible to a regular system. Then a regular system takes the quantum results and interprets them. Think of it like a team effort. QML is doing the heavy lifting of finding patterns in the data, while the classical system puts the pieces together. QML is like having a team of highly trained, very expensive athletes working on a task. At first glance, it may not seem efficient, but when you consider how much faster the task is completed, the cost is quickly justified. So now that we know how quantum machine learning works, let's see how it's being used to change the game in the field of quantum computing. Quantum AI builds the first chip. Using quantum machine learning, the Australian researchers tackled a problem that has long plagued the semiconductor industry, the fine-tuning of transistor layers. If you don't know what a transistor is, don't worry, you're not alone. Basically, it's like a tiny switch that controls the flow of electricity, and it's the building block of modern electronics. Specifically, they were looking at GaN HEMTs, which are popular for their high electron mobility, making them ideal for high-speed, high-power applications like 5G devices. Now here's the thing, when you stack different layers of materials in a semiconductor, you get something called a heterostructure. These heterostructures are like little sandwiches made of different kinds of materials, and they have unique electrical properties that depend on how well the layers are matched. One of the key parameters that affects this is called the ohmic contact resistance, which is basically how easily electricity can flow between different materials. The lower the resistance, the better. And it's this simple, right? Well, not exactly. The problem is that measuring this resistance is kind of difficult. You can't just pop open a transistor and take a peek inside. You have to do a lot of testing and simulations, and even then you don't always get the best results. Enter quantum machine learning. The team used a quantum algorithm to analyze data from 159 gallium nitride transistors and identified the factors that affect the resistance. The algorithm found that the resistance depends on the number of periods, the thickness of each period, the period-to-period distance, and the position of the gate on the transistor. Okay, great, but what does that mean? Well, if you're a chip designer, this is like gold. You can use this information to create new chips that have lower resistance and operate more efficiently. You can also use it to improve existing designs. In other words, quantum machine learning can help us make better chips. Who knew that quantum mechanics could be so useful? But wait, there's more. The researchers didn't just stop there. They also compared their quantum algorithm to 7 leading classical machine learning algorithms, including deep neural networks. And guess what? Their algorithm outperformed them all. It was able to predict the resistance of new transistors with a remarkable degree of accuracy. Let's take a closer look at some of the details. The quantum algorithm used in the study is called the Quantum Kernel Aligned Regressor, or QKAR. It is a relatively new development in the field of quantum machine learning, and it is specifically designed to handle problems where the input and output variables are continuous rather than discrete. This makes it ideal for things like predicting the resistance of a transistor where the values can take on any real number within a range. CARM is a supervised learning algorithm, which means it learns from labeled data. In this case, the team provided the algorithm with data from transistors that had been previously tested, and the algorithm learned from that. Once it had learned enough, it was able to make accurate predictions about the resistance of new transistors that it had never seen before. Another key feature of QKARTM that it's a kernel-based algorithm. This means that it uses a mathematical technique called the kernel trick to map the input data into a higher dimensional space where it can more easily find patterns and relationships. This is particularly useful in this study because the relationship between the input variables and the output variable is nonlinear. The algorithm can capture these nonlinear relationships more easily than traditional linear models. One of the most impressive aspects of QKAR is its ability to align quantum and classical data. This is done through a process called the quantum classical interface, which allows the quantum computer to process the data a way that is more suitable for the classical algorithm. This alignment is crucial for making the predictions because it ensures that the two algorithms are working in harmony to achieve the best possible result. And here's the bottom line. QKAR is a relatively new development in the field of quantum machine learning, and it is already showing some amazing results. Its ability to handle continuous output variables, use the kernel trick, and align quantum and classical data makes it a powerful tool for a variety of applications, including predicting the resistance of semiconductors. Who knows what other breakthroughs it might help us achieve in the future? In conclusion, the Australian team has made a significant contribution to the field of quantum machine learning. By developing a new quantum algorithm and applying it to the problem of predicting the resistance of semiconductor layers, they have shown that quantum computers can be used to solve real-world problems with practical applications. One of the key strengths of this research is the interdisciplinary approach. The team brought together experts in quantum computing, machine learning, and semiconductor physics to tackle a problem that has long plagued the industry. This collaboration resulted in a novel algorithm that leverages the unique capabilities of quantum computers to solve a problem that was previously intractable. Another important aspect of this research is the use of a new quantum algorithm. CARM is a promising development in the field of quantum machine learning, and this study showcases its potential. The algorithm's ability to handle continuous output variables, use the kernel trick, and align quantum and classical data makes it a versatile tool for a wide range of applications. Finally, the experimental validation of the algorithm is a major accomplishment. The team was able to test the performance of their algorithm on real-world data from actual transistors and compare it to leading classical machine learning algorithms. The fact that QKAR outperformed these algorithms is a testament to the power of quantum computing and the potential it has to revolutionize industries such as electronics. Overall, this research is a promising development in the field of quantum computing. It shows that quantum computers are capable of solving real-world problems with practical applications, and it highlights the potential of quantum machine learning to revolutionize industries. As quantum computing technology continues to develop, we can expect to see more breakthroughs like this that push the boundaries of what's possible. So what do you think? Are you excited about the potential of quantum computing? Let me know in the comments below, and if you enjoyed this video, please don't forget to subscribe for more updates on all things AI. Thanks for watching, and I'll see you in the next one.